Okay, so continuing our discussion of the LLM reasoning layer. Uh, so let us see a diagram first. We'll come to the planning layer later. We'll discuss the reasoning layer in depth first. So we can consider the LLM reasoning layer in terms of this diagram, which basically represents the React agent architecture. So React agent architecture means three things. First is reasoning, second is acting, and third is observing. So we will discuss each of these in detail. Reasoning, as we discussed, is basically interpreting the current situation, the current state of the agent, and determining what is the best next action to take. Acting is executing that specific action that we have decided, that the agent has decided upon, or you can say the reasoning layer or the LLM has decided upon, and you execute the action using the available tools that the agent has. Observing is seeing or observing the result of that action, the results of those actions. So in observing, we loop back the results back into the reasoning layer or into the LLM. So it has got more context now, on the basis of which it can plan its next step. So this is how it works. So you have a task or a question or a query, and then you have this reasoning layer, which primarily consists of an LLM. It interprets the task based on like whatever the current state is, decides an action to take. That probably would be an execution of a tool. So it executes that action, that is acting, and then it loops back the result of that action back into the reasoning layer. That is the observation. So this is the React loop: reasoning, acting, observing. So this is a very popular agent architecture, right? So in this specific scenario, uh, both the reasoning and the planning layers are merged into one. So we have a single node consisting of one LLM instance that is doing both the reasoning as well as the planning. So this is sufficient for simple and medium complex use cases where you don't need to separate the planning part into a different layer, and this suffices for most of the use cases. Right. So I'll show you how this thing is implemented in the email assistant. So we'll touch this briefly. So you can see the React loop in the design of the email assistant. So this planning step, so this is a node in the agent graph. So this is your reasoning and planning node. So, and this is being invoked by a sub-agent. So these different planners are sub-agents. On top of these sub-agents, we have a router node. So when an email comes, this router node classifies the email into a specific category, and then it routes the execution to a specific sub-agent. The sub-agent then invokes this React loop. So each of the sub-agent has got a system prompt where we define the personality of that sub-agent and what specific purpose it is meant to achieve. So we describe in detail in the system prompt of that sub-agent, and then we pass in that system prompt and any additional data to the React loop. So based on the system prompt, right, and whatever data is available, this reasoning and planning node, it decides the uh, next action to take. It has got a number of tools available. So the LLM that is present in this node, it has got a number of tools at its disposal. So depending on whatever reasoning and planning it has done, it decides to execute, let's say, a specific tool. So this is the execute tool action, and the results of the tool execution is fed back into the reasoning and planning node. So this can go like in multiple cycles till the agent achieves the specific objective. The sub agent achieves the specific sub objective that it is meant to perform. So uh, this is the React agent architecture, right? So we'll take an example to discuss the execution flow. For example, like you ask a simple React agent a question, who is the CEO of OpenAI? So it goes into the reasoning and planning mode. Basically, the execution comes to that specific node, and then it thinks about the question. So it realizes that it doesn't have the necessary information in its internal knowledge base, and it also realizes that it has got access to a web search tool. So it decides to call the web search tool with this specific query. CEO of OpenAI parent company, it gets the results back, and it sees that the search results indicate them that Sam Altman is the CEO of OpenAI, and multiple search results basically confirm this fact. Further, the chain of thoughts, uh, it confirms this thing that the information it has received is consistent across different sources, and then it has got sufficient confidence to answer the question without hallucinating, and then it gives the final answer. So if we actually perform this thing in chat GPT, some issue here. Let me try Google Gemini. So right. So basically, what it is doing, it's performing the same React loop execution behind the scenes. So you can see like it is citing the sources from where it has got this information, and these sources it gets by the execution of the search tool. So this is your React architecture in action. Now coming to the planning node or the planning pattern. So we use this explicit planning node or a separate planning node in case our use case is complex, and in that scenario, like we